Good afternoon. Welcome to a session on HITRUST and HIPAA. Anybody out there ever gone to your doctor's office and had to arrive a little early to fill out a few forms to protect your health information? That's what HIPAA is all about. It's been around for quite a while, and of course HITRUST is the Health Information Trust Alliance that federates several different security and compliance standards for healthcare systems. It's very prevalent in the commercial healthcare environment, and in the public sector environment for healthcare organizations, they look at HITRUST as well as some of the other security organizations. My name is Laura Glass. I am from Infor. We are a software company, ERP software, and we are a primary provider of healthcare back-end operations software in the HR, payroll, financial management, supply chain, particularly clinical operations, interoperability. We have a Cloverleaf interoperability solution, and security and compliance is top of mind for our healthcare customers, not only in the commercial sector, but also in the Defense Health Agency, the military treatment facilities, the Indian Health Service, and of course the VA. So I hope that you're going to enjoy a full hour of discussion. Brad Dispenza is an expert from Amazon Web Services and is going to get into some of the details around HITRUST and HIPAA. And let me just have him come on up to the stage.
Thank you. Howdy. So today what we're going to be going through is some governance strategies for enabling a workload on AWS for HITRUST and HIPAA-based compliance. So first I want to kind of address the elephant in the room is, am I in the right place? There are a lot of talks going on right now, and so hopefully everyone wants to talk about HIPAA and HITRUST, so that's the first bar. The next part is, this is initially sort of a 300 level talk. So what that means for Amazon is that this is meant to be a more advanced talk. The assumption is that you already have a little bit of general understanding of general AWS terminology. So things like EBS, EC2, VPC, IAM, these are terms that you're generally familiar with. This is not a sort of 101 talk on how to use basic services in AWS. So generally it's more, I get it, we do stuff, but I want to learn more. I want to understand how to better use a solution on AWS. So no one is sprinting for the door yet. So you're still here? Great. So first, I want to give a quick summary just in case folks are sort of new to this space. So first, HIPAA, Health Insurance Portability and Accountability Act. Passed in '96, went into effect in 2003. The important part for you as a customer for AWS is how you implement a HIPAA-based solution on AWS. For us, what we do is we take our FedRAMP process, which is 853, and NIST 866, which provides a good crosswalk between 853 and 866. And also, we do the same process with the security rule, which is the CFR Part 160. So basically, you can use this as sort of a templatized approach for how we map controls inside of AWS. HITRUST. So as we talked about when we first got going with the session, HITRUST is a little bit different. So HIPAA is a government program. HITRUST came from a consortium of partners, basically. So the difference is that HITRUST is a little bit newer, so founded in 2007. It's a nonprofit alliance of companies. Much like NIST now, it establishes a Common Security Framework, or CSF. So the idea is that basically you take a number of different compliance packages like PCI and ISO, even HIPAA, and you sort of blend them all together to get a best of breed solution to really, in some cases, raise the bar on security. HIPAA is a little bit more longer in the tooth. It's very general and quite frankly open to a lot of interpretation, even within the community, on exactly what controls need to be implemented and how they are implemented. And HITRUST is a little bit more prescriptive in that way. It gives you a good matrix that you can use as part of their CSF package that will actually even walk you through the different compliance packages. So that said, I want to apply governance on my account. So we have an account on AWS. This is an account that's going to be subject to either one of these. How do I deal with things around governance and control for my account? So the first thing is that we want to look at something around like an organizational policy. And so for AWS, what that means is that we can leverage a service like AWS Organizations to make sure that we're pushing policies appropriately to our accounts, and so that there's a good governance strategy for how we provide access to resources. Now, if any of you are AWS customers right now, you may be wondering, well, wait a minute. Orgs is not on the approved list for BAA, so why are you talking about orgs in a talk for HIPAA? So it's important to remember the rules for your BAA. Does your use of the service actually store, transmit, or process data that would be subject to HIPAA regulations? If the answer is no, it's okay to actually use every single service in AWS for a HIPAA-compliant workload, but the only ones that can be used to store, transmit, or process data that would be subject to HIPAA regulations or through your HITRUST certification, those go through eligible services. So only eligible services are the ones that are able to do those key functions. But everything else can actually be used. So a good example is that today, if we were to look at a service that would be outside of scope that we want to use in the service, it's okay to actually use it, again, just as long as that it doesn't actually store, transmit, or process the PHI. So for orgs, generally speaking, orgs does not store, transmit, or process PHI. But that said, don't take this as like a challenge to figure out a really cute way to inject data that would be subject to regulation. This is something where we want to look at using it for its intended purpose. So when we have these discussions, it's really important to understand that also part of our HIPAA guidance and guidance for HITRUST is that it really falls to the AWS shared responsibility model. So for a lot of this, there are controls that are mapped that are things that AWS manages, and there are controls that fall to you as the customer. So the important takeaway is that when you look, especially for HITRUST, a lot of the controls that are spoken for Amazon for your HITRUST certification align with AWS controls that already exist for things like our ISO certification. So you can use that in concert when you actually go to perform your audit to have those findings basically be no-op. So that's something that AWS is now responsible for. But a key thing for you as the customer to know is that I've spoken with a number of customers that sort of get confused on this point. So being on AWS does not make you HIPAA compliant and does not make you HITRUST compliant. There's still a portion of the stack that is responsible to you. So a really good example, or how would you sort of make this simple? If you were to deploy a web-based application and you were to front-face it to the public internet, wide open, with a default login of root and password 1234, that would be a horrible design pattern. But it would also be your side of the shared responsibility model. That's not something where Amazon would be responsible for that bad design choice. So you want to make sure that you're still employing the same safeguards and controls that you would normally employ in your existing environment. So going back to orgs, the mechanisms that we would use for an organizational use of orgs for a HIPAA or HITRUST account is that we want to group accounts into organizational units or OUs. Basically for management and convenient purposes. So if we're a large organization, we can have multiple orgs spread out across our environment, or we can use a single monolithic one and use those orgs as subcontainers. AWS accounts and OUs have to be a member of an OU, so you can't have satellites floating out in space. It has to be sort of a symbiotic relationship. So there's an OU that's nested within, say, a master OU that we're going to touch on in a second. Also, an AWS account can be a member of multiple OUs, and that's basically stacking OU policies down. So it's sort of the proper org and then sub-OUs. So we're going to dive into how that flow works in a second here. So here what we're looking at is basically a number of accounts. So we've got accounts that we want to use for different purposes in our environment. So let's say that on my side anyway, the left side of the screen, or yours is I guess the right, we want to have a set of accounts that are specifically used for research purposes. So these are going to fall under maybe a mixed use case of whether or not they would or wouldn't be subject to regulation. Then we have ones that are, say, explicitly going to be used for a HIPAA-based workload. So these are clinical care providers. These are researchers that are absolutely doing clinical trials or something that would, without question, fall to one of those regulations. That's where we can use something like the HIPAA OU. And then when we want to have services maybe that are public-facing and we want to treat those differently, we can organize those logically together into something like a public services OU. So the way that we use this from a control perspective and from a governance perspective is that we can apply service control policies to the organizational units. So basically what this does is it allows you to describe a set of controls that we can say for how a resource should and shouldn't be allowed to operate within its particular OU. The important part is that these can be attached to a master organization, to an individual account, or to an OU itself. So if we look at this as sort of a played out example, here we've got at the top, let's say, our master organization, and that has a default policy that's been associated with it for all OU members, right? So the idea is that basically for every single account I have in my environment, this is the baseline that I want to set for everybody. So we've come up with a standard that says we want to do things like enforce a consistent use of the service, or we want to whitelist or blacklist services for the entire organization. That's something that can be set on the highest level. Then below that, we've set a policy on the group on the right. And so here the idea is that for this specific OU, we're going to apply policies on top of the policy that was used at the first highest level. And then for account 9, that one's special. It's a production account, but it's a separate production account. So we want to apply a separate condition set to that. That's how we would do it, is basically associate those to that account 9. Now, account 9 is basically going to get all of those policies rolled up to it. So it's going to get the top level one and then the OU associated with it as well. And then we can also do that same workflow through, here in this case, account 3, I think it was. That will get the master policy, but when we move that account to another OU, so let's say that we were doing this in the research environment and now we want to promote it to a production service, that policy will still stick with it, but the policy now that's being pushed down through the production OU will also now be inherited to that resource. So the important part for this is that basically the way that the service control policies work is that it gives you the ability to do API whitelisting or blacklisting. So for organizations that are more conservative, what they can choose to do is basically specifically whitelist only AWS services that are approved in the eligible service list. Now, generally, as I said at the beginning, you can use every single service within an AWS HIPAA-based workload. And I would argue that generally you don't want to constrain your developers and the folks actually running workloads by taking this heavy-handed approach. But if you're a very conservative organization and you want to make sure that there's no room for error, this is a good example. We can basically say that these accounts can only use the whitelisted-based services. It's also important to know from a governance perspective of, well, what happens if somebody that's in one of these has root level permission? So they're running their account, they've got the master account, they've got administrator access, can they go and modify my permission? And the answer is no. That's something that would be not capable of being overridden as membership in that OU. An important part here is also that the policy basically is sort of an intersection between IAM and the service control policy. So what I mean by that is that it has to be done in unison with an IAM policy. And I'm going to give you sort of a specific breakdown. The other part that's important is that if you're using IAM and you're new to the platform, it's hard to do least privilege on AWS when you're first getting started because there are so many different APIs. So how do I know which one is right? How do I know how to properly test that environment? And the answer is that there's something called the IAM policy simulator. So you can use the IAM policy simulator to actually go and test a permission set and see if the intended effect will work in the way that you're expecting. And it's important to note that it is aware of the service control policy capability. So here's a blacklisting example. So what I've done essentially is said that I want to allow basically everything, but explicitly deny anything on the Redshift side. So we're saying we're going to say everything's okay, but for whatever reason our organization has said that we don't want Redshift used, we're going to explicitly deny Redshift. And then the inverse is basically, if I wanted to do a whitelisting example, here is where I'm basically saying I want to allow EC2, but I don't want to allow every EC2 resource. I want to allow a specific subset of those APIs. This is where I can then, again, have a much more granular policy that speaks to basically, in this case, run and describe. So I want them to be able to launch an instance and then be able to see it in the console. So as a more practical example, though, in that sort of Venn diagram discussion I was having with OUs and orgs, you can also do things like create a security audit account. So this is important is because within those service control policies, you can assign actions, and I can do things like create roles, even cross-account roles. So for this diagram, what I'm doing is basically creating a specific security account which maybe has a long-lived credential that the security team is doing. We want to enforce a stronger barrier for control for those users, so we're using multi-factor authentication. And they have the capability of assuming a read-only role in those child accounts. So why would you do that? The reason is because I want to be able to do things like ingest those accounts' CloudTrail logs. So CloudTrail, if you don't know, is basically a service that will go and record all of the API activity that's taking place on the platform. So for an audit perspective, this gives you a really good story around provenance for how resources came to be, who has modified them, how did something actually come across. The other thing that's important to call out here is that in that service control policy, we can do things like set the fact that we want a service to operate a certain way. So in this case, what I'm saying is I want CloudTrail to flow to a specific log data bucket. So we want to configure our CloudTrail logs basically so that when we create an account, we always point the CloudTrail logs to an account that's controlled by the security group. Why would you want to do that? Well, you have to think like an attacker, right? So for the folks that are more security-minded, what's the first thing that you're going to do when you get into an account and start trying to get a foothold? You want to erase the tracks that you use to actually get into the account. And if your logs are stored in the same account and that person has gained administrator access out of the gates, the first thing that they're going to do is try to wipe those logs out. So by taking those logs and storing them into this security account, we can make sure that basically we're increasing that bar for entry, right? Now that person had to have access to that security account, and we've already talked about that we're locking down access to that through things like multi-factor authentication. Likewise, we can also do things like help them configure things like CloudWatch alerts. So when a particular event happens in your environment, we can put an SNS topic in the security VPC and then make a subscription to that. So that basically when things happen like this is the HIPAA account, we want to make sure that these only communicate through our VPN connection. Anything that would be a publicly facing IP address is something that maybe a VPC flow log would trigger against. And we can then take that topic and make that something actionable. So how do I deal with account access? So now we've got these accounts that are floating out in space and we've set some policies on them. How do I deal with actually getting people into those resources? So from an identity and access management perspective, we need to first figure out who actually needs API or console level access to our resources. This is kind of a no-duh in a lot of respects, but I've been really surprised by the number of customers that don't understand the difference between IAM, console level access and API access, and application access. So you only give people access to AWS APIs and consoles that actually need to perform operations on the platform. So these are folks that are going to launch an EC2 instance, modify a VPC, change a resource. You don't give these permissions to someone that's running an application in your environment. So if I built you a web server and you run your workload on my web server, you don't get identity and access management capabilities because you don't need them. You run solely based on the actual application itself. Another area, especially for large organizations, is when possible, leverage identity federation. So rather than using specific IAM users for those privileged accounts, tie that into your identity store. And the reason for that is when you go to have a user maybe change roles in your organization, or maybe they separate from your company, you likely have a process in place that walks through decommissioning that user from your directory environment, but you likely probably wouldn't remember to have to go into that AWS account and terminate that account. So by coupling that with your directory policies, you can go and make sure that when that account is decommissioned from your AD environment, let's say, that will also cascade down to your AWS environment. Likewise, we want to do things like security best practices. So if we're giving that federated user capabilities to get into our environment, we want to look like possibly leveraging things like MFA. So if you're using Shibboleth, we can point to your Radius servers prior to that. If we're using roles for these accounts, we also want to look at things like making sure we're using least privilege. So least privilege is something that's really easy for me to stand up here and say for you to do, but in practice, it's something that's very difficult to actually do. So what we do is we give you some tools to help you better understand how your users are actually using the platform so that you can better scope down on what those users are actually capable of doing. So again, separation of duty. Does my developer need access to IAM? So we just said, don't give people access to things that they don't need. Well, this is that edge case. Normally, no. A developer wouldn't necessarily need access to AWS if you're provisioning them resources. But it's important to call out sort of an edge case scenario where I have, say, a CloudFormation template that requires the capability to use an IAM permission. So it's assuming a particular role or it's doing something outside of that least privilege set. So what do we do in this situation? So this would be a good opportunity to do something like leverage an IAM role. So for the Linuxy folks in the crowd, this is kind of equivalent to using something like a sudo command. We're temporarily bumping up our permissions, and then we're dropping it once the command is actually complete. The other important thing here is when you're sort of scoping this out, it's important to not think of the user necessarily as the boundary. You can also think of the account as the boundary. So if we have a workload that's maybe higher risk, it doesn't have to necessarily be that we're scoping down that user's permissions. Maybe it could be that we're actually putting this in a completely separate account in our organization as well. So as an example workflow for that situation where I was saying we're going to use that IAM role, here basically this user, the developer, has the capabilities launching a subset of permissions, but I want them to launch this CloudFormation template. So here what we would do is basically launch this user to the ability to assume a particular IAM role to call out to, say, an S3 bucket. And that S3 bucket is containing a particular stack that we want to launch. And that secure template then has the capabilities of assuming that role's permission to then push that workload into production. Another important call out is consider necessarily not putting your code in the developer's desktop, right? So have it so that your environment is no longer storing information on the end user's devices. For the folks that didn't hear, last week we just announced that Workspaces is now a HIPAA eligible service. So the reason that that's really empowering is that for most clinical organizations, what you probably are doing, especially for if you're regulated, you're enforcing things like encryption policy on your end device or your laptop, right? So while that's really all well and good when you go and have a user that maybe forgot their backpack on a train or worse, it was stolen from a vehicle or from their desk, you still have to go back and basically now prove that the encryption was active on that device, right? So an auditor will ask basically if there's going to be a finding, especially for HIPAA, you need to prove that basically the encryption capabilities was active. And heaven forbid, I actually had a customer where they weren't logging their encryption checks with the service, and so they actually weren't able to attest that the device was encrypted even though they felt fairly confident. So with Workspaces, we can deploy a secure environment for them to work in the cloud. The only thing that's being pushed over the wire is pixels. From there, we can do things like use VPC peering so that when they work in their secure enclave, basically they're using the workspace as a pivot point in that network to then talk to that secure network, which has, let's say, no internet capabilities whatsoever. It's a private network where that researcher can work so that we can know that the application that they're using has no capability of actually communicating with the outside world. So again, I talked about that least privilege design, something really easy to say but hard to actually do. So how do you actually know what users are doing? So from IAM, we have the Access Advisor. The Access Advisor is listed as a tab within the IAM console. That will give you a good high-level overview of at least what services are being leveraged for your account. So you can look at, for instance, my IAM user and say, what things has Brad actually ever used? And it looks like I've only used EC2, VPC, and let's say Redshift. Everything else that's in that account I've never actually used. So now I can go through and start reaping basically those privileges from that user or that group or that group. The other thing that we can do is CloudTrail audits. So when I want to actually look at what that user is doing, again, all API activity on the platform is logged. So if you're in the console clicking around, or you're actually making API calls from the SDK or the CLI, every single one of those is logged within CloudTrail. So if we look at that in aggregate, we actually have a really good blog post now that uses Athena to actually query these logs out of S3 and gives you a good summary of all the resources that are being leveraged through CloudTrail. Also on the IAM policy side, and for folks that haven't noticed, as much as I can, I'm actually referencing policy language on the bottom, so as it's applicable, these are the HITRUST and HIPAA regulations in the lower left-hand corner. So things like enforcing password policy and rotation, making sure that if a user has been issued something like an API key, have they ever used that API key? So we've given them both a password capability and API activity. If they've never used their API key, why don't we just auto-revoke it? And when they actually need to use it, they can go back and request it. But better to not have something out there floating that could be accidentally checked into GitHub or accidentally left on a machine and read maliciously. Use the tools that we give you. So Trusted Advisor is a really powerful tool to help you save money and get information about performance, but it also gives you really good information about best practices on AWS. And specifically in the security context, it will tell you if you're doing things that we would consider dangerous. So in our environments, doing things like having port 22 open to the entire world, there may be a legitimate business purpose for that, but that's something that maybe you want to look at as higher risk. And Trusted Advisor can help you find some of those. It can also help you find things like misconfigured credentials. So Trusted Advisor is really easy to run on one account, but if you're dealing with a large organization, it becomes a little bit more of a tricky thing. The nice part is that Trusted Advisor is something that you can schedule through the API. So what I could do is basically, again, use that cross-account role capability from the security account to run a batch operation against all of the accounts that are out there to basically do, say, get a morning Trusted Advisor check. Now, I should also point out there are a number of third-party tools and partners that will give you the same level of information about API activity on the cloud as well. So what about encryption inside the VPC? So the answer is absolutely encrypt everything. That's part of the BAA, is that we basically say you need to encrypt anything that would be subject to those regulations. How do we make sure that we're actually encrypting our data? So for S3, we have things like a bucket level policy. For EBS, we have things like the service config and config rules. So for EBS, I can do things like say, anytime a user goes and creates an EBS volume, and they create it in, say, one of our secure enclaves, I can look at that API call and make a decision about whether or not they made that volume with encryption. If they're outside of our compliance, which is that they must have encryption enabled, we can do one of two things. And this goes to how your organization culture works. You can make the decision right there to basically terminate that resource and take it offline, or you can basically use that API call to then issue a secondary API call to, say, your ticketing service and open a ticket and let that user know that, hey, you've configured a resource that's outside of compliance. You have 24 hours to remediate, otherwise we're going to kill it for you. You have to kind of find the right mix for your level of risk that you're comfortable with, especially being outside of compliance, but also a good balance between how your users feel about your governance in their account. The reason I'm specifically calling this out is that if you take the heavy-handed approach, users that feel like you're getting in their way or that you're doing things that they don't like are often unfortunately kind of more inclined to go and create their own accounts outside of your organization with like a credit card. And then they start doing things that are no longer outside of your policy, that are no longer in your scope, and you have no visibility into it, right? So you want to try to use the carrot and not the stick as much as possible. Again, another mechanism that we can use to help enforce this is things like templated policies. So using tools like CloudFormation, we can deploy artifacts to them that make sure that we deploy things in a repeatable, consistent way. So if we know that all of our customers are asking for a particular design template, like help me use our best practices to stand up a VPC and give me a base architecture, we can templatize all of that and give it to them so that it's something that they can do and know that basically it's enforced in a correct way. And then, of course, there's third-party monitoring tools as well that help you get insight into all this. It's worth calling out the encryption part obviously speaks to KMS. So KMS is very tightly integrated with our SDKs. This is how you actually perform cryptographic operations by default for services like EBS and S3 and Redshift. The other important part is that because KMS is making API calls, it again goes back to that design pattern of we can see those in the CloudTrail logs, so we can look at that again for things like has a user performed an operation like a decrypt when maybe they weren't authorized. An important part, especially for regulatory and compliance activities, is that, again, that log can be used to help make that attestation of we are doing this and here is specifically how we are doing it. Another important part, though, to call out is that people tend to focus on KMS as just being, kind of cool for keys, but the real power in KMS is actually grants. So the key policies are things that you can use that are more broad, right? So they're more static in nature. These are less frequently changing. Grants can be used in a more dynamic way so that I can set context for an operation. So plain English, what does that mean? I can do things like say that only a decrypt operation can take place if it's coming from a particular VPC and through a particular endpoint to a particular resource. So you can get very granular in the way that a resource can actually be used. And again, that helps you with that least privilege journey. Code secure. So we want to make sure that we're basically storing our code in a secure environment. So things like using the EC2 parameter store. So rather than basically storing your sensitive passwords in clear text, which again could be checked into GitHub or someplace outside of your environment, don't do that. Use a service like Parameter Store to save those in a secure enclave, which is used in KMS in the background, to make sure that those are securely stored, but then they can be programmatically injected when you want them to be. So a good example, though, is if I were to deploy, say, a CloudFormation template to stand up a basic 3-tier web architecture, where I want to go and inject a MySQL password into the environment. We actually have a really good blog post that you can go through that will walk you through each of those individual steps to actually creating that parameter and then actually injecting it at runtime. So the attribute is never persisted ever to disk. It's stored as an environment variable. So this is a call out to that blog post, and then I've got a link at the end as well if that's something you're interested in. Securing the network. So again, last week we made a number of changes to the HIPAA eligible services, and some that I want to specifically call out. CloudFront, WAF, and Shield are recent additions to the HIPAA eligible service list. So the reason that's significant is that, again, when we think of how we can better secure our environment, we want to try and push that threat as far out to the edge as possible. And CloudFront is one tool that you can use to really help in that. So when we're deploying, say, a web-based application, we can now use CloudFront as an outer layer to make sure that resources aren't actually communicating with our backend server. But more importantly, when we're looking for things like common attack vectors like SQLi injection or bot detection, that's where WAF can come into play. Also important, especially for clinical organizations that maybe are putting public API endpoints out for their patients, we want to make sure that we're not subject to, say, blackmail, where someone's actually coming to us and saying, we're going to put a DDoS attack against your service unless you pay us 50 Bitcoin. So what Shield can do is help mitigate that DDoS concern, both from a Shield standard as well as if you want sort of an insurance policy. Shield Plus can help you not only with getting that DDoS mitigation, but can also give you access to dedicated engineers that will help you through that DDoS response, and even in some cases recoup some of those costs. So I want to create an 853 or an 800/171 compliant environment now, but I don't know where to start, right? So I've read through the matrix, but I don't really quite understand. So there was a really great site that we launched about a year ago, which is Quick Starts. So Quick Starts basically gives you templatized, pre-made environments that you can literally click a button and get an environment that will give you a Jenkins build. But in this case, what I want to focus on is that we have a NIST-compliant environment. So if I wanted to go and stand up an 853 or 800/171 compliant environment, you can use this quick start to help you in that journey. Now, again, as I said before in that shared security model, launching the template alone will not give you this environment. There's still a level of configuration that you need to do on your side. But an important call out that I wanted to specifically put an arrow on is the security controls matrix. So the security controls matrix is about the coolest thing outside of the template itself, because what it will do is actually walk you through the different controls, and then it points out basically for each control where the responsibility sort of lies in that template. So is this something that AWS is speaking to, and how are we speaking to it? Or is this something that you are going to be responsible for and you need to address in your design? So again, this is a really cool way to accelerate building an environment that has been hardened to a NIST standard. So how do we deal with audit? So now we've got a good strategy for creating users our environment. We've got a good strategy for creating our account environment. Now the auditor is going to come through and they're going to start asking questions about, how are you performing something? So I want to walk you through some logical Rosetta Stone style matching of what a common term would be and what the AWS equivalent would be. So for logging and auditing, this is something where we want to look at leveraging something like CloudTrail. When we want to look at things like asset management, who knows the pain of basically being in a data center and saying, tell me every single server that you have in our environment and what it does. We'll get back to you on that, right? In AWS, it's as simple as running an EC2 describe call, right? So using things like config in the API can definitely help you on that asset management side. Managing access and controls, this is again something where we look at identity and access management. Config management, this is again where we can use the web console, OpsWorks, CloudFormation. Again, these are tools that you can use. OpsWorks specifically I'm calling out because if you're not specifically injecting that data that would be considered PHI, you can use the service, but the second that you step over that line, it needs to be a HIPAA eligible service. So use them as templates, but don't necessarily use them to store or transmit or process PHI. And then an important call out is monitoring for CloudWatch. So CloudWatch is an awesome service that will give you information and metrics about how your resources and how your environment is being utilized. But you can actually also pump logs into CloudWatch. And this is one of those examples where you need to understand your side of the shared security model. So CloudWatch can help reduce the burden of dealing with storing logs and making sure that you actually have the capability of automatically acting on a log event, so looking for a particular number of failed login attempts. But if you're putting PHI into your logs, this would be an example of don't use CloudWatch, or at least don't put your log data inside of CloudWatch. You can still use it for metric information, but you wouldn't want to store it for the actual log information. Data in flight, so obviously this is where we're going to use something like IPsec or TLS or your own solution. For volume encryption, again, we want to look at things like EBS encryption. Object encryption for S3 obviously falls through S3 encryption. Well, we want to look at things like a requirement for a dedicated HSM. We talked earlier about KMS. So KMS is unique in that basically we are controlling access to those keys, and we give it to you in a very programmatic and tightly bound to AWS APIs. But at the end of the day, if you read through our cryptographic details white paper, the sole source of that key material still falls to AWS. And for some organizations, they're regulated in a way that it doesn't allow that to actually take place. So they have to use something separately. And that's where the Cloud HSM comes into play. So the important part I would call out for the Cloud HSM is that it is a physical device. It's a SafeNet Luna, actually. So when you design your workload and you design your environment, we always want to, as Werner Vogel says, plan for failure, right? So things fail all the time. So when you go to deploy a solution with the Cloud HSM, it's important to remember that it is a physical thing. It's a single one thing. So if I have all of my keys stored on a Cloud HSM and that HSM fails, you now have no capability of recovering any of your data. So you want to look at making sure that when you design a solution that it's highly available. In the case of Cloud HSM, we would probably want to deploy these in pairs. If you already have an HSM through, again, SafeNet already, it can actually be joined to that cluster. So that's how you would do that. And then for database encryption, again, these are where we would want to leverage things like TDE and EBS encryption with KMS to those volumes if we're running EC2 instances. And again, for Redshift, KMS is what's actually going to be used in the backside. And then on the networking side, Internet or Direct Connect, so DX is now part of the HIPAA eligible services, so we can use that for how we're actually transmitting information to our environment. And then from there, basically, it kind of breaks down when we want to do things like firewalls. This is where security groups come into play. So how do I get help on my workloads? You've told me all about all these great tools that you help, but we're a newer company. Maybe we just don't have the technical expertise in cloud yet. How do we get started on our journey? So if you have an AWS account, I've always kind of been surprised by this, whether you know it or not, you actually have an account manager and an SA that is actually associated with your account, every single one of you, if you have an account. If you've never spoken to them, I highly suggest that you do. And one of the cool things that you can do is engaging that SA, you can have them come in at no cost and sit down with you and talk about your architecture, talk about your design, make sure that it's actually meeting your regulatory and compliance requirements. And this is a free service, so absolutely take advantage of that. There are also AWS professional services that can be brought in, and then absolutely partners. So AWS can help you through that process, but in general, we can't write code for you. We can't actually create a software solution for you. That's something where you either need to have in-house developers, or you need to look at something like a third party where they can actually go and help you actually create that software. How do I see the AWS BAA? So good news. This is, as of a couple hours ago, just announced. So you are actually now able to get a copy of your BAA through Artifact. So if you go into the Artifact, you'll see there's a new tab that just got released, which is the BAA FAQ. And within that, you can actually go and read about how the BAA is now accessible through Artifact. The important part that should be called out for larger organizations, and you'll read about this through the FAQ, the first time you do this, you will have to go through a click-through agreement because now you're associating a master account with that access to that BAA. But now this allows you to do things like through Artifact, I can modify my accounts. So if we want to add a new account as being a new HIPAA eligible account for our environment, we can do that through Artifact. So in summary, it's not just one thing when we want to deploy an application so that it leans for a HIPAA or HITRUST environment. We want to look at, as much as possible, leveraging AWS services that lower that barrier for entries for you, but also lower that burden. So whereas, as much as you can, use AWS managed services. Services like RDS, where it's applicable for the engine, it really lowers that operational burden so that you don't have to have someone focused on actually caring and feeding for your database. Let that be something that falls to the AWS side of the responsibility matrix. And that is all I have. I'll stand up here afterwards and take any questions off on the side, but thank you all very much for coming in, and happy to answer questions on the side if you have any.